Hey, what's up guys, my name is Cherno and welcome to episode 24 of the Sparky game engine series in which we make a beautiful game engine from scratch in C++. So, last time we had the amazing experience of creating audio files. Press the wrong key. No, I didn't. What is up guys, my name is Cherno. Oh, I should have started the episode off with that. Maybe I should re-record it. I will re-record it. Alright, are we ready? What is up guys, my name is Cherno. And welcome to episode 24 of the beautiful Sparky game engine series in which we make a game engine from scratch in C++. So, last time, as you can probably tell by my awesome intro, we did audio, and we had the ability to do a lot of cool stuff. What is up guys, my name is Cherno. What is up guys, such as loop audio and stop it and do whatever we want with it, which is pretty cool, and even increase the volume and whatnot. What is up guys, my name is Cherno. You can see that's decreasing the volume. Anyway, best. So we with that, and the reason I'm so happy is because we're basically done. This is what I like to call an informal code lock, because we're basically done in terms of adding features. All we're going to do now is fix existing features. Now, this episode's all going to be about the mscripton preparation. The mscripton preparation is going to be about basically just this is almost going to be like a maintenance episode. We haven't really had a real version of those like we really haven't had a real maintenance episode because we've basically just had issues and bug fixes, but we haven't really sorted out minor stuff. And this is what this episode's going to be about, because next episode 25, we're actually going to be compiling Sparky into JavaScript using mscripton, which is a big deal. It should go generally okay because I have done it before, but there are issues with this that will prevent us from doing that. The biggest issue right now is Guerrilla Audio, which is what we did last time. Guerrilla Audio, and I mentioned this several times, is only going to be used for desktop, okay? Windows, Mac, Linux. For the web, we're going to use JavaScript for all audio stuff, and we might even use some kind of JavaScript library, I'm not sure. We'll probably just do it via plain JavaScript though. So that's fine. We don't have to worry about that. Everything else though, including free image, I've decided now, has to be compiled into JavaScript, okay, via mscripton. So because of that, because mscripton is going to have such a big job, we need to kind of clean this up and make sure that it's generally flawless. So to do that, we're going to spend this episode basically just going over a few minor things and fixing them up. So the first thing I wanted to do was last episode I finished recording that like 15 minutes ago. I actually forgot to, so we had this playing equals false in the pause, but we didn't set it back to true when we resumed it, and we had quit here for some really weird reasons. Let's just fix that up a little bit, and I'll actually pop this after these things. No, I'll leave it there. Just because, in case that fails or whatever, it doesn't do it again. Anyway, that will be fantastic. So, one thing we should do is also, if playing, return, because we don't want to resume if it's already playing. And same here, if it doesn't actually do anything, I'm pretty sure, but yeah. So if playing, return. So if we just test that out really quickly, because that was a minor thing that I kind of forgot for some reason. What is up guys, my name is Cherno. Okay, that seems to work. Okay, great, so that's done. Now, one of the biggest things we had was textures, so we'll save that for last, but there are a few little things. First of all, static friends. What on earth are they? They're not actually a thing. Obviously, if it's like a friend, it can't be static. So let's get rid of that, because it's not even part of the class, so it can't be static if it's a friend. Let's get rid of that. Okay, gone. That was just not correct at all. The other thing that's not correct in terms of C++ was in my batch renderer, in renderer, I had a const mount4. You can't actually have const types inside vector, okay? That's not good, so we have to get rid of that as well. Alright, anyway, those are very minor things that we just needed to clean up, because mscripton, basically Clang would have which is a different compiler, would have complained about that. Whereas the Visual C++ compiler is just like, yeah, it's fine. So that's important. Okay, that was easy. Let's probably fix the texturing issue. Oh, there were a few different things that I needed to... there was one more thing that I wanted to do, which was the tile layer, because that shouldn't be part of our class. This is going to be a quick episode, by the way. But the longest part of the episode is going to be now, which is when we have to fix this texture stuff. So right now we support a maximum of 32 textures. Yeah, what happens after that is, as you can see, it flashes, but it doesn't really like clear it or anything. It's not something that we do. We should do that. It needs to clear them every frame, basically. So what we want to do is this. We want to have a hash define up here, which is called renderer max textures, and we'll set that equal to like 8. Right now it's 32. We're just going to set it lower. We'll probably set it to 2 or something just to test it in a minute. And what we'll do is in m texture slots, so we'll change this to be renderer max textures. We do all this stuff. That's great. So yeah, you can see it has to end, flush, and begin. Now, what happens is when you flush it, okay, we need to go clear on these. So it clears all the textures out. Done. In fact, we could do that up here, but whatever. We'll do it here. Okay, so now that's cleared. So let's just run it. It should run exactly the same way. Some might say it's a little bit inefficient to do that. It's not really. I mean, I think we were getting 5,800 frames per second before in release mode. Let's just check it again. Clearing a vector is quite fast. Well, not the clearing part, but like that is fast, but because it doesn't actually clear it, doesn't delete it, obviously. Yeah, its performance is the same. In fact, it's actually performing better. When we play a sound though, does it really drop?
What is up, guys? My name is Cherno.
No, great. So that's good. It's actually, I don't know why we were running slowly before, but whatever. Great. So now that we've done that, we need to probably drop that to something very small and see if it still works. So, how many we've got? Like, let's just drop it to 2 and see what happens. I think we're using 3 textures, so we'll see. We have to make this work though. Whoa. Look at that performance. What? What? Did you guys see that? Wow, we're doing something very wrong. Let's quickly just verify that. Holy guacamole. So like 6.5K, I think, right? Or 6K FPS. And if we drop the max textures to 2, we go down to like 200 frames per second. Oh my goodness. So just to encourage, like, we could probably find our issue, the issue ourselves, but I actually want to run this through the profiler. Because I think it'll be more fun. Oh, not in release mode though. Out. Oh, actually, does the release mode... Did we set release mode to have inlining? Any suitable? Let's change that to disabled. You can go away. Ugh. Okay, this is interesting. I have to say I did not expect that. That is very low. So, yeah. See how many draw calls we have actually. But that should be enough. Let's just see where all the performances are going, because we could be doing something wrong. That's seeming likely. But the other thing you have to realize is that reducing this to 2 is going to kill everything. So it looks like that is that. So why is it okay, so it looks like we're actually fine. It looks like what's going on is the majority of our time is actually spent in OpenGL, 96%, which tells me it's not anything we're doing. It's just the fact that it's actually begin. So this map buffer is taking the most time. Yeah, so it's not something that we can actually fix, unfortunately, because it's just submit is taking the most. Let's go into submit real quick. You can see that nothing in submit, including our texture stuff, is actually taking the most. It's just the fact that you can see that since this happens very frequently, okay, it needs to flush what it's currently got and begin again. So what we could do quickly, just for curiosity, is we could give, let's just say, yeah, so we could probably count the amount of draw calls that actually goes into this. So just to do this in a kind of dirty fashion, I'll just make a static int DC draw calls equals 0. We will, every time we flush, so every time we draw elements, we'll increment our draw calls. And then, once per second, so this is going to be, no, that's going to be draw calls per second. We want draw calls per frame. So we'll set that back to 0. And then before we update, we will we'll see how many draw calls we're getting. 0. What a solid number. Why? 0. That's so weird. Wait, is this... Hang on a minute. What? That's a bit weird. What? Is this being reset somewhere? That is weird. Oh, wait. No, that's fine. What on earth? Okay, let's not go that way. Let's ignore that approach. Let's pop it in here. That's a bit weird though. Okay. No, what? Alright. $93 draw calls. Okay? Ridiculous. So, 93 draw calls per frame versus versus 1, which you'll see if I go into renderer, bash renderer H, and I set this back to like 8 or whatever it was. We'll set it back to 32 because that is really the max. You can see we're dealing with 1 draw call, okay? And you can see that's why it's much faster. So that's an important lesson on draw calls as well. So we'll change it back to 32 because that is good. We'll get rid of this draw calls variable. That was just for testing. But now you can see it does still work when we go past the max textures now. As you can see, our scene looked exactly the same. We fixed it so that it does work. All we had to do really was clear it. But it's good. So that's the important thing. We'll get rid of that and that. Okay, fantastic. So we should be back up to pretty fast speed. Okay, one more place I forgot to remove it. Alright, great. So that's pretty much it. I wanted to remove tile layer. We'll do that, and then this episode's basically done. Okay, that's a bit slow. Should be 6,500, shouldn't it be? Maybe it's because I'm streaming or something. I don't know. Performance measuring is a bit dodgy. Okay, before we unscript it, let's also profile it. Anything else I wanted to do? There was something shaders, default shaders. Should this be the default shader? Stop profiling. We could make a default shader. Oh, I know why. Oh, what? What? Okay, that's interesting. But okay. I know why it was slow though. That's so weird. I know why it was slow though. It's because we disabled inlining. And that gets rid of like 2,000 frames per second, as you can tell. Okay. So we should be back up to like 6K-ish. Yep. Great. So we're around 6,000 FPS, as you can see. Fantastic. And we're drawing quite a lot of sprites, which is nice. I'm pretty happy with this. So let's get rid of tile layer. So one thing I wanted to mention, and I mentioned this off recording but on stream, is we've got this tile layer. This is not supposed to be part of the engine, clearly. Like it's pretty much an empty class and it has a projection matrix hard coded into it. This isn't actually supposed to be part of the engine. This is an example of what you would implement yourself. Okay? So what I mean by that is yeah, this is something that you would pretty much implement yourself. So outside, so when you're making a game, you'd make a tile layer, you'd make a debug layer, you'd make a text layer, a HUD layer, UI layer, whatever, right? This is an example of how you would do that. So this is not something that you should be doing here though. It's not something that should be part of the engine. So we're going to delete it. I don't actually want to delete it though, because I want to just copy it and put it outside. So I'll grab this, I'll copy it, and I will pop it into Sparky core and into like next to main, because that's like our example. And then I'll come over here and I will, under layers, tile layer, I'll just delete that, and I'll delete the files as well. Okay, so now main's going to complain. Main is the only thing that should complain, right? Nothing else should care. And it's only complaining here. So all we have to do is include tile layer.h like this. And let's refresh this. Tile layer like this. Include in project. Okay, and let's just pop sound under. Oh, we didn't have that. Audio. Audio. Okay, so we're cleaning a few things up, as you can see. All right, great. String utils should be in utils, and tile layer should just be here. Okay, great. So, oh, what happened to sound? Ah, here it is. Okay, so a few things. First of all, this is not a namespace that we'll be using. This will just be no namespace, because it's not part of Sparky, part of our test game, which will be in whatever namespace you want. This has to include source. Oh, sorry, it doesn't have to go back. Source, graphics, layers, layer. Does it need the batch renderer? Oh yeah, it does, because it creates it. So we should make headers which have all this stuff as well. Source, graphics, batch renderer. So Sparky, graphics, layer. You should never use using namespace, obviously, in headers, by the way. I hope that's apparent. And then this will just extend that. This will just use this. So you can see we've now kind of taken this out of the Sparky stuff. It's now just completely part of our own kind of game. And if we run it, it should run the same, but now it's no longer part of Sparky, which is good. That's totally right. Like, you'll create layers. That's what I mean. Based on, like, if you want to use a different shader, you'll just create a new layer. That's how it's going to work right now. I don't know if I'll ever change that, actually, because it, like, maybe when 3D stuff comes along, possibly, but for the most part, you probably, especially in 2D, you probably won't have too many different shaders anyway. So, fantastic. That's done. Anything else? So what I wanted to do is create, right now what you have to do is, okay, let's get rid of this, by the way. This is our Gorilla Audio test file. Let's get rid of that. And I think there's some, like, yeah, like this stuff. We don't need any of that. So we had font manager. This is like a test thing. So we had audio, and then we had, so there's some graphics buffers, graphics layers. We got a lot of different stuff here. And just graphics as well. Static sprite. We should probably get rid of the simple renderer entirely. To be honest, it's never going to be supported. Yeah, we'll get rid of it. Say goodbye to the simple renderer, guys. It's getting deleted. What else do we not need? Static sprite. So static sprite and if you want, like, it'll still be on GitHub version control, but I'm getting rid of it. So yeah. Sorry. Graphics, static sprite. Remove and delete. It's gone. Renderer, simple 2D renderer. Remove, delete. All right, let's just build this again. Make sure everything's still good. Should be. No one misses the. No one misses those guys. Yeah. Yeah, so I was gonna make a main loop kind of thing elsewhere, but I'm actually gonna save that for the Unscripted episode, I think. Is there anything else I wanted to do? Yeah, default shaders are a nice idea, but I don't think I'll do that because it's just not really that necessary. Yeah, I think we're done. This is a quick episode, but I hope you guys enjoyed the episode 24 of Sparky. Next episode, we're going to be compiling all this stuff into Mscripton, and it should be the best. So, hope you guys enjoyed that. And maybe I should make 24.5 as well, an episode, because I really did want to cover the main loop kind of stuff. Let's do that right now, actually. I've decided on the fly, live, let's just do this now. So, under source, which is in the Sparky thing, I'm actually going to add a new item, which is going to be a header file called Sparky. Okay, .h. So what happens is, if you're making a Sparky application, you want to where's the file I just created? That was a header file. Yes. So if you're making a Sparky application, you basically include this header file and override things, and everything is the best. So that's kind of the way it's going to work. So pragma once, namespace Sparky, class Sparky, and it'll have some private stuff, it'll have some protected stuff, and then we'll fix up Mscripton as well to work with this, don't you worry. So public, so it'll have a constructor, and this will be header only because you'll only include it once anyway. We should have so public, we'll have a public constructor, and we'll have like void. Really everything should probably be protected. Let's do that. There shouldn't be anything that's public, I don't think, in this. Void, okay, so we'll have a few things, and I'll explain what they are. We'll have init. So this is a virtual void init, which is going to be, so most of this is going to be pure virtual. We'll have init, we'll have 4 things. We'll have init, we'll have tick, we'll have update, and you guys are going to be confused because you'll be like, what's the difference between tick and update? And you'll find out. And render. And we might have like some kind of shutdown thing as well. In fact, that'll probably just be the destructor. So we'll make a virtual destructor. I don't think the constructor will probably do much. It might log a few things, but I don't think it'll do too much. Make sure that's virtual. Okay, so what happens is this runs when oh, and we'll have to have start as well. So this will run init and run, and I'll explain all this stuff in a minute. And run will be private. Void run. So this will have the main game loop. So we also need to create window, don't we? So window will be handled probably by this class. So include graphics window. So we'll have a graphics window and window. That'll be a pointer. Over here we will delete and window. Looks like we'll have stuff here after all. We'll have a no, I guess we'll make it we'll let people retrieve it. They'll need to because for input and whatnot. So graphics window, create window, or create display. I think window probably sounds nicer. So this will wrap whatever this does. So we'll grab this stuff. I chose to do this episode just because it was a bit short. So the other episode, that is. So okay, so m window equals new graphics window, name, width, height, return m window. Okay, it runs once upon it. So this runs once per second. So tick is going to run once per second. That's a useful thing to have. Update is going to run 60 times per second. It doesn't really matter if you render things in what was I going to say? Yeah, it doesn't really matter if you render things in the update method or anything like that, since these aren't running on different threads at the moment. I don't know if they will in the future. I haven't decided that yet, but for now they're not. So anyway, this is looking pretty good, and we could even have stuff like get FPS and all that cool stuff. So we'll make that stuff in a minute, but I just wanted to add a little bit of documentation. You have to implement all of these clearly. Okay, so void start is what you call to start this stuff up. Okay, good. Okay, run. So let's just copy our game loop. We're not going to exactly copy it, obviously, but we'll copy it a little bit. So what do we have here? So we've got a bunch of. We need to make a texture manager. That would have been nice, but too late. Code lock. Well, this is kind of probably going against that, but anyway. So while m window dot closed. So here's what we're going to do. This is basically going to handle a lot of the stuff for us. So we had a timer, didn't we? This stuff. So this was our once per second timer. We had a frame counter, so we'll count frames. We'll just do that. We had... we just had a timer, didn't we? We we probably want to start it when it actually starts though. So what we'll do is this. We'll make it a pointer. We'll make pretty much everything in this class a pointer, I think. We'll start the timer over here. So when you actually run it, which is what happens when you run the start method. So window.update and frames plus plus, all that stuff happens in here. We need, so there's our timer. That's clearly the wrong one. I think we called it time, didn't we? Oh, okay, that's the only time we actually used it. Oh, we had a timer as well. Fine, we'll call it time. We'll call it, actually no, we'll just call it M timer. And we'll have a different timer. That's make it confusing, but whatever. I was going to go into the header file, but I'm already in the header file because it's implemented in the header file. Anyway, so and window dot update or pointer update. Okay, cool. So get out, yes. We need to have an unsigned int frames. I might actually just make a type def called uint, which is unsigned int. I haven't done that thus far though, so I'm probably gonna avoid doing that. Okay. So there we go. Let's clear the window. Clear the window. We want to render in here, and then we want to update when we're 60 times per second. So right now, we could probably make another timer that does that, like a float delta kind of time. So right now we're doing that, and that's once per second. So let's do this. Let's make a just thinking the best way. Here's what we could do. Oh, I think we might just make another update timer. This might actually be better. Let's not set it equal to that though. Let's set it to, we set it to time to elapsed, didn't we here? No, we didn't. We set it to 0. Oh, that's because it, yeah. Oh, okay. That's interesting. So, we'll set it equal to 0. Fine, doesn't matter. And then we'll say, float, I don't know, update, tick. I'm creating names at this point. We'll set to that, and we'll say if timer elapsed. That's M timer. Well, that did not work out. M timer dot elapsed is greater. Oh, sorry, minus update timer. So we're doing kind of a similar thing here. Is greater than update tick. Plus equals update tick. Yeah, there's so many different ways we could have done this, but this is one of them. Might refactor this in the future to be better. And then we'll do update. Okay, cool. That looks pretty good. So we could have a protected. Yeah, so let's have updates per second. So we'll set we'll set that, and then we'll have in protected, I guess. Why not? Const int, const unsigned int. With those unsigned ints, which probably initialize them to 0 as well. Okay, get FPS. That'll get updated once per second, clearly, and then get UPS, updates per second, not the shipping company, UPS. Okay, I'm feeling pretty good about this. Hopefully everything is the best. Sure seems like it. Okay, great. So how would you use something like this? That's the next question. This is our kind of test game right now. How would we use something like this? So let's go into main, and let's just shut the whole thing off so it doesn't actually get compiled. We could just remove it from our project, but I don't want to do that. Let's go into show all files here. Let's make a folder called examples, and let's add a new item, so called game.cpp. So this is officially, and all of you should probably listen up here, because this is officially how you write a game in Sparky. So big news. So what you want to do is first of all, let's include sparky.h, which apparently is in the same folder. That's wrong. I hope that's wrong. It is wrong. Good. So you probably want to actually add it into your include directories, but it doesn't matter. Yeah, we don't want to add it into the we probably should have made this in a different project, actually. Doesn't matter. This is an example. Source sparky.h. Then you probably want to make a game class and a main method. A main function, I should say. So you extend or you inherit from Sparky. It's safe to say, using namespace, Sparky in this case, because we're in our game.cpp. So you're doing that. You probably want to have a constructor, and you can have this as a header file if you like. I'm just running it here because I'm lazy. We'll have a destructor. You will want to have a destructor. Okay, and then we'll have a few private members probably as well. Okay, and then what we do is we make a game, and then we go game.start. Whoa. Visual assist. I just got visual assisted. Hope that didn't like destroy everything, because that seemed to do a few things. Dodgy. Yes, so obviously we can't do this yet because we have to override everything. So void. So I'll make this the case. You're not going to get forced to override tick, which happens once per second, or we're not calling that. Tick should happen here. And let's just lower this so it happens after the method. So tick should happen now. So you're not going to get forced to do this or update. So all you actually need is init and render, and that's it. Those are the only ones you're forced to actually do. So let's just do init. I'll make that as override. You don't have to, but you can. And render. Okay, so start is inaccessible. Oh, start needs to be public, I assume. What happened here? Goodness, we did something. Visual Assist did something to us. Oh, please still build roughly. Good, thank you. Okay, anyway, on the bright side, it looks like this is building. So, here's what we want to do. So we probably do want to store a window. In fact, I'm just going to use pretty much all the namespaces. So, window, window. Oh, I could probably just, use that. So we'll set window equal to create window. Test game 960 540. We'll probably make a layer. So this is good because it also encourages you to actually see what's going on. So we don't have to delete the window. Luckily that gets done for us. We do need to delete stuff like layer though. So layer, okay, so this needs to include layer. This needs to include a lot of stuff. So layer includes a lot of stuff though, so we'll leave it as that for now. Okay, we need to make some kind of layer class as well, probably. We should make some kind of simple layer thing as well, that should be a thing. We'll figure out though, because I don't think you can, is this capable of doing things? Yes, it just needs to, okay, no, that's good. I'm happy I did it that way. So include maths.h. Okay, so we'll go layer equals new layer, and we'll make sure that we don't forget to delete it. Layer equals new layer. Oh, yes, thank you, Polymathic, who just reminded me in the stream that I need to do this. This is very important and should be covered this episode. This text IDs thing has to happen by probably the shader or the layer, basically. So, right, so this setting of these textures, okay? So I need to do that. So yes, thank you. New layer. What do we want here? We want a renderer. So we can just go new batch renderer 2D. Again, this is something you'd handle yourself, but new batch renderer 2D, which we'll have to include here. What's the next thing? A shader. So new shader. Shaders get tired. Yeah, they do. So source shaders basic.vert. Basic.frag. And we'll still we deleted it. Maths mat4 project sorry oh yeah, we'll just do orthographic. Left, right, bottom, top, -1, 1. Okay. Whew. I bet. Yeah, so that'll be including everything. Let's just compile this quickly. Oh, it's projected. No, we won't make that a thing. We did make this a thing, but I've decided against it because it could be good for quick creation of things. Like this. If you just want to quickly make a layer. Because it implements everything anyway, doesn't it? Oh, I guess it does depend on the renderer though. Let's quickly just verify. No, it doesn't. Okay, great. So, yeah, in fact, Tile was right. Tile did nothing really except call the constructor properly. Okay, cool. That's done. Okay, layer's done. So let's submit a sprite. That's not a thing yet. New sprite. So 0044. Texture, we can just set a color. And then over here we'll just call layer render. So that's looking pretty good, I think. Let's just run that and see what happens. I doubt this will work. But hey. It's just, I mean, I've typed like 4 lines of actual code. Oh, no, it will work. So it's still using our other shader, which is pretty funny. Yeah, so it's, I guess it says the light to, I guess the uniform had a default light or something. I don't know. Anyway, that worked, which is nice. You can see our test games here, and everything totally works. Which is nice. Oh, yes, there's something very bad in the font rendering that I just remembered about. So this is what this episode's about, clearly. Just all this scampering. This scaling. That is terrible. Oh, that's so bad. What's a quick way to fix that? So there should be like a set scale thing per font, probably. Yeah, we'll do that. That's the easiest way to fix this. So, so we'll have a scale, and we'll have a void set scale, float x and float y. And we'll have a get scale. Okay, cool. And I'll quickly implement that. Okay. So this is in font, right? So maths vector. Okay, so now in our batch renderer, we'll grab the font, and scale X and scale Y were used in plenty of places. So let's just say const maths vec2 scale equals font dot get scale, and we'll make that a reference. Obviously, we don't want to copy those values. Scale.x, scale.x, scale.y, scale.x, scale.y, scale.x. Okay, now we can get rid of this. Okay, so now it was, yeah, so it was basically width divided by whatever. So we'll say when we create the font, so there is the default font. So if we, can we just do that font manager? Is there a font manager? There should be a get that just gets the default one. I've just thought of it. I'm gonna add so many new features. So this should just return mfonts 0. And that should definitely be a thing, because it will be. Anyway, okay, that's main. We don't care about that anymore. We're way past that. So let's go ahead and say font manager get set scale to mwindow dot get width divided by 32, which is 32, by the way, is the range of it's our horizontal range. And we'll set the height. Oh, it's just called window, my bad. To 18. Okay, great. So that should still work now. Oh, we're not actually rendering any fonts. Let's render the FPS or something. So I'm getting a bit carried away, and we're actually just making a game now. What's up with this? Already has a body. Oh yes, my bad. So label FPS. Okay. Whew. So we will set FPS equal to a new label. I think we've got a lot of options, don't we? Yeah, we can just do that. So we'll set the x and y equal to like minus 15.5 minus like 8. Color to white. Add, yeah, so visual is nice for that. Add FPS. Oh, you know what we could do? See, at this point, we can override tick. And set FPS dot text equal to get FPS. Which I think is an unsigned, but whatever, the version should totally work. Let's just try this and see what happens. So the lighting is probably stopping that. I really should get rid of the lighting. Like, that should definitely happen, because clearly it's not. It shouldn't be here. Like, that was just a cool kind of feature. Okay, so I'm not seeing my font. Oh, hey, yes I am. It's not going to happen after the first second. But it says A. That's weird. What? Let's try that. There we go. Okay. Oh, that position looks wrong though. Oh, wait. It is. My bad. I meant to do that. Okay. Sweet. Let's move that down a little bit. But yeah, it looks pretty good. So you can see how easy it is to make a game in Sparky. That's it. I mean, it's not really a game, obviously, but it pretty much is. Yeah. So there you go. I could add a texture pretty easily as well. We've got a test texture, right? If I wanted a texture, I just go new texture. Test.png. And that should just work. You can see it did. What's another different texture that I could try? tb.png, for example. No problem. There you go. Ooh, problem. That's actually my bad though. Okay, so that comes up to us not setting this stuff up. So this should happen. this should happen by the layer. So the layer should do that. The thing is, it probably doesn't want to... Yeah, we'll just do it here. This is what we'll do. Yeah, I'll just do it here. I was going to... I was going to make it inside a for loop, but I thought, why bother? Oops. I'll just have this beautifully aligned. Two. So this kind of enforces shaders to support textures. I guess it doesn't really. If it doesn't find the uniform, it won't post it. But there you go. All right. Setting all of our stuff here. 32. Yes, that's correct. And then that's it. And it's called textures. So let's just build this. And so why is this? Oh, it's. Oh wait. Yeah, that's right. Wait, weren't we enabling it? Yeah, we're enabling it up there. Okay, so now it should totally work. Apart from the pointer. Yeah, so you can see now the textures are working correctly. Cool. There you go, guys. It's just as simple as that. We're pretty much complete. So, yes. We can get rid of this because that will actually break code. But so can we set a sprite's position easily? Not right now, right? I mean, renderable probably has. No, it doesn't. Yeah, we could make it so that we... Let's quickly expose that for sprite. The same way that we did with label. So if you remember, what we did with label is we made a reference up here that was public called position. So that's what I'm going to do with this as well. I'm going to... In fact, renderable should probably just have that, but I'll just add it for sprite manually. So... position, we'll say it's M position, right? And this is just handy because you'll see why in a minute. And because we want to control sprites positions pretty easily anyway without any kind of function calls, or it'll inline it, but this is just better. So what we'll do is we'll make an we need to make sure that we're doing the right amounts of updates per second, because my timer, we don't know if that works. So let's try updates per second, and that should be 60, 59, 60, 61, that range. What? No, we must be returning the wrong value. Yes, we're returning frames per second. Take two. Come on, timer. Yes. Okay, good. So that's good. Time is happening that many times per second. Let's change that back there, and we'll also print out that as well. Let's override update, and we will say, so right now this sprite is kind of in here. And then we'll we'll say if window is key pressed, GLFW key up, then sprite dot position dot y plus plus. Oh, that's probably gonna be a bit fast. And we made a little game. Pretty amazing. I mean, it's more of a graphics test than a game, but you guys get the point. And we're not demoing stuff like audio, but whatever. Oops. No, that's minus. That's plus. So let's see. Look at that. Oh, right doesn't work. What? Oh, lols. My bad. But yeah, check that out. Pretty cool. Oh, and I probably should not be else-ifing those things. Otherwise we can only move in two directions. Oh, and rather than one direction. Not diagonally. There we go. Pretty amazing. And you can see how easy it was to make that game. It's this. So I'm gonna end it there. I hope you guys enjoyed that. Let's quickly make a well, the last thing I wanted to do, I promise, the last thing I wanted to do was I just set this light position. We could do that in update. So window is that, and shader is that. Oh, we didn't make a shader up here. We should probably have a layer.get shader as well, but whatever. So yeah, I'm actually quite happy with how flawless this works. Pretty good. Yes. Such beautiful code. Awful. This window position stuff, that's fine. Okay, and now if we go to basic and we re-enable this, we'll find that we're all good. You can see, there we go. And you can move around and whatnot, and you can shine the light, and we've got inputs working, and everything seems to be going pretty well. So anyway, hope you guys enjoyed this episode. There was one thing this is a nitpick, but you see how it prints 0 first for the first tick? That's because the data hasn't been populated yet. We can fix that by going into Sparky and just popping this tick over here. You can see now it works because it will tick after it's got that data, which is good. Alright, any questions, leave them below. As you can see, Sparky is pretty much a fully functional game engine, a basic one, but it works. And yeah, next episode will be mscripton, so that's going to be fun. And I'll see you guys next time. And if you enjoyed, please hit the like button. Goodbye. Whoa.